involving electronic configurations. So I'll be showing you some tricks on how to know, using the electronic configuration, on how to know the group that an element belongs to, the period an element belongs to, the block, okay, that an element belongs to on the periodic table. And also, we can also use this trick also to know the kind of the valence electron of the atom of an element, and also you can know which kind of bonding such element can actually partake. Alright, well, let us go. Alright, let me use I'll make reference to two elements. I'll make reference to, let's say we have X and we have Y. I hope you can see my screen. Alright, then X has this electronic configuration of 1, S2, 2, S2, 2P6, 3, S1. And this one has 1S2, 2S2, 2P6, okay, that's 10, 3S2, that's 12, then 3P5. Good. So I'll see questions, okay, coming like this, telling you, okay, what is X, what is Y, asking you what group does X belong to, what group or period can you also find Y. This is very, very simple. Now, I'll tell you two things. In this kind of configuration, okay, we are expressing, showing you the atomic orbitals and also their energy levels, that's this and this. But in a short way, first of all, the numbers you are seeing on top, okay, that are superscripts, they are representing the electrons. You understand? They're representing the electrons. So if I count now, I have 2 plus 2, that's 4, plus 6, that's 10, plus 1, that's 11. Take note. So this element now has 11 electrons. Look at this one, 2 plus 2, that's 4, plus 6, that's 10, plus 2, that's 12, plus 5, that's what? 17. Okay, this also has 17 electrons. Now this brings you back to ask you the question. On the periodic table, which atom, okay, in their ground state has 11 electrons? Which element on the periodic table, okay, in their ground state has 17 electrons? Can somebody say it? Okay, you should know, right? Okay, this is going to be sodium, and this is what? Chlorine. You're correct, you're correct. So let's see now. Now, using this electronic configuration, there are other ways I can write it. For 11 now, I can write it as 2, 8, 1. Okay, 2 plus 8 is what? 10 plus 1, 11. This one, so I can write it as 2, 8, 7. Do you understand? 2 plus 8 is what? 10 plus 7, that's 17. So now, let's go now. What group and period can I find these elements having this configuration? What's group? What's the group? Alright. Now, this is the trick. For you to know the group that an element belongs to by looking at their configuration, okay, just look at the number of electrons in the outermost shell. So each of these arrangements, okay, shows what shows the shell that every element belongs to. So this one is the first shell, second shell, and third shell. Okay, so we can say simply that since the electronic configuration shows that what there's only one electron in the outermost shell of this element, okay, it belongs to group 1. So this element X, okay, that we don't know the name yet, okay, is in group 1. Why did I say that? The number of the electrons in the outermost shell represents the group number of that element. I don't know if it is clear. Good. Okay, now how do I also know the period? Simple, very simple. Okay, look at it. Each of these represents what? The shell. Okay, so this is the first shell, second shell, and what? Third shell. So the number of shell, okay, of an element, okay, describes the what? The period. So if I count it now, this is first shell, second shell, third shell. So I'll say this element belongs to period 3. Period 3. Okay, so this element belongs to group 1, period 3. How do I know? Just by what? The configuration. So if you come to this as well, you can know. Simple, very simple. Okay, the group, just as I told you now. If you look at it now, this is what? 1. Okay, this is the first shell. Okay, this is the second shell because they have the same energy level. That's 2, 2. Alright, forget about this atomic orbital. This is 2, 2. So they are in the same shell. That's that is the 8, this one, okay? Then you have how much electron? This is 3s1. This is another orbital, okay? Okay, with a higher energy level. So from here now, you can simply say this is what? Only one electron in the atmosphere. So which is what? Group 1. The period as well. This is the first shell, the second shell. Just look at the number 2, okay? Then one, first shell. That's, you have it as well. That's period 3. So lastly, also, you can also come from here. Okay, the block, it belongs to the block. Now, how do you know the block that an element belongs to? Just look at the shell, okay, or the atomic orbital, okay, where the last electron, okay, resides. Where you can find the last electron, that is the what? That is representing the what? The block. Just like this now. What do you see here? You see 3s, that's what S, okay? So you can say this element belongs to what? Group 1, period 3, and what? Block S. Very, very simple. You can check your periodic table to verify. So this you can also, okay, you can do this by yourself and tell me the answer in the comment section. Okay, so summary down. This one, we can really say that this is sodium, okay, having what? 11 electron, 11 proton. Are you with me now? Then we can also talk about the valence electron, which is what? It has what? Just one valence electron. Do you understand? And then we also know that such element is a melter, okay? So it can participate in what we call ionic bonding or electrovalent bonding. Alright guys, I want you to expect more videos, okay? Like, comment, follow, and share this video if you find it interesting and educative. Cheers.